Hey everyone, how it goes and welcome back to Computer Science 145. Today, we're going to continue discussing classes and objects. We're going to continue the big example that we established in the previous lecture. Here is our problem. I like to travel around, and while I like to travel, I like to enjoy one of the world's most perfect food, a taco. Now the problem that we're solving is we need to keep track of the tacos that I like. We are engineering solutions to these problems by using software. And it was introduced in the previous lecture that we're using what's called the waterfall model in order to create this software. The waterfall model consists of a couple of parts: gather the requirements, design the software, implement the software, verify it by testing it, and also maintaining it. Now going through a few of these parts. The requirements was the software needs to keep track of important taco information, such as its name, location, and price. The software should be able to add tacos, remove tacos, sort them by price, and display all the taco information. The software should also have a clear and simple front end. From there, we started designing the software by using a UML class diagram. Each one of these boxes represents a different class, and each one of these has different sections. The top one is the class identifier. The next one are the properties, like the instance variables, and the final one is the methods that each one of these classes can do. In the last example, we implemented the taco class and part of the taco manager. Today we're going to finish implementation. And before we get to that, let's go over a couple of very important elements that was discussed in that previous lecture. Now we're going to focus on the taco manager, and before we get to that, we need to discuss an array of objects. So first of all, an array of objects are simply an array of just memory addresses. In Java, arrays are also considered to be a class type. So just like all class types, the identifier only holds a reference to the contents. Now furthermore, an array of class types, in other words, an array of objects, contain memory addresses that refer to the object itself. The default values for object arrays are all considered to be null. The purpose of the taco manager was to maintain this data structure, this array of tacos. We should always structure data in such a way that makes the problem solving easy and efficient. The way that we decided to structure this taco array was simple. We were going to keep every constructed element to one side of the array. The first null element indicates everything after it would also be null. Now, when we were going over adding, what we did was we started from the first index. Once we find that first null element, let's say right here, then we add the reference, the memory address to that object. Now if we add another one, notice here that's not null, but the next one is, so we add the other reference there. And then if we add another one, the first one's not null, second one's not null, but this one is. And now everything past that is also going to be null. Today we're going to start by focusing how we can remove elements from this structure. So let's say, for instance, we were going to remove this first taco. Well, the easiest way to do this is to simply set this value to null. But wait a second, this breaks the rule of how we're structuring this data. When we encounter this would indicate that everything after it should be null, but notice this isn't null and this isn't null. We want to keep all constructed elements to one side of this. So doing it in this way would be incorrect for how we're trying to structure our data. What we should do instead is just replace this value with its neighbor, then replace this value with its neighbor. In other words, we should shift all the memory addresses over by one. When we do that, it will now look like this. But now, how does that remove it from memory? If we remember back from a previous lecture, the way that we can get rid of objects in memory is to forget its memory location. As we no longer have a reference to the object that was at memory address 86, Java, being a memory-managed language, has a mechanism called a garbage collector. It goes around and it scans through the memory, and if there is no way to access that object, then all it does is remove it from memory. By shifting over all of the memory addresses, we simply forget where that memory address was, and it is removed from memory. Now, that being said, let's see how we can remove elements from this array. Now we're going to create the method public void remove taco. Now, how were we removing this taco? Well, it was established before. We're going to search for the taco's name. Now, the first thing we need to do is find the taco with this given name. Something that we should recognize is that, simple enough, we may not have a taco with this name at all. So what we're going to first do is create a sentinel value. We're going to create int remove index is assigned to -1. We understand that an array cannot have a negative index. This sentinel value indicates if we search through this entire array and we do not find a taco with this name, then it didn't exist. Sentinel values are excellent to use when we need to signal a certain type of condition, like for instance, we did not find this taco. So now we need to search for it. We need to examine every single element inside this array. So first we create for int I is equal to 0, I is less than tacos.length I++. Now we need to check if tacos at index I. The first thing we need to check is if the element in this array even exists. So if tacos at index I is not equal to null, that means that taco at least exists. And if this taco at index I, because remember, this is the reference to the array. This is a reference to one element in the array or one taco. So we need to check this taco's name. How do we get that taco's name? I just said it. We can use the accessor .getName. Now the name is a string. And in order to check this string versus this one, we need to use the .equals method. Now notice this. This is the reference to the array. This is the reference to one element inside of this array. Now by calling this method, it returns a string, so this entire thing just becomes the type string. So this means after that method, I can call another method .equals an. So if this taco's name is equal to this parameter, then we found the taco that we need to remove. And so we're going to reassign the remove index is equal to I, and we're going to break out of this loop. We found it, now we need to remove it. Before we do that, we need to check if the remove index is still equal to -1. Now this would indicate that we did not find a taco with this name. And if this is the case, we simply call return. Notice I'm not returning a value, I'm just using the word return. The reason why is this is a void return type. I'm using this to simply stop the method, so it's going to return immediately outside of that method if this is true. But if this is not true, otherwise, what we need to do is now shift all of the memory addresses over. So watch. For int I is equal to the remove index. This is the element that we're about to remove. While I is less than tacos.length I++. Now we just assign its value to its neighbor. Tacos at I is equal to tacos at I plus 1. Now before we move on, this will cause an error. What type of error will this cause? Now let's assume that our taco array is the default size 10. That means the last valid index is index 9 because 10 minus 1 is 9. Well, here's the thing. 9 is less than 10. That's true. However, 9 is then assigned to 9 plus 1. That's 10. That's an index out of bounds exception. So in order to do this, I need to subtract 1 from that value. Now, if we successfully remove this taco, we also need to ensure that the last element is null. To do that, we write tacos at tacos.length minus 1 is equal to null. And now, by doing this, we can successfully remove a taco by its name. We have to remember that an array of objects is simply an array of memory addresses. Class types are separated from their identifiers, which holds a memory address, a reference to their contents. The way that we do this is first we find the taco with its given name, then we remove it by shifting over all of the elements by 1. This also keeps our data structure maintained, because the main idea was the first null element in this data structure means that everything after it is also null. We keep all of the constructed tacos to one side of this array. Now let's finish writing the functionality. Let's sort the tacos. Private void sort tacos. Now the reason why we made this scope private is I've made the design decision that I do not want this functionality to be accessible outside of this class. In fact, the only time this functionality is ever going to be called is right here. This is inside the add method, and every time we add a taco, we're then going to sort it by the price. So before I move on, I'm going to take out this to-do sort, and I'm simply going to call this .sort tacos. That way, we add a taco, and then we sort them. Now, there's a lot of different types of sorting algorithms, and I'm just going to use bubble sort for simplicity's sake. I'm going to first start by creating boolean swapped is equal to true, and then while swapped. We then assume that swapped is equal to false. And now, the way that bubble sort works is we look at every side-by-side element. We're comparing this based on the taco's price. So if we find a taco's price that is greater than its neighbor, then we need to swap its values. So in other words, for int I is equal to 0, I is less than tacos.length minus 1, I++. Now once again, we understand there could be blank elements. There could be null elements in this array. So simply enough, if tacos at index I is equal to null, or tacos at index I plus 1 is equal to null, well then we need to break. That means either this or this taco doesn't exist, we can't compare them. But if both of these are false, that means we have a taco here and a taco there. We need to compare the prices. So if tacos at index I, now once again, this is the array tacos. This is one element. This is one taco. Now I can use the method getPrice in order to get this taco's price. And if this taco's price is greater than its neighbor, tacos at index I dot getPrice, and make sure you add 1 to it, then what we need to do is swap. So I'm going to create a taco temp is equal to tacos at index I. Tacos at index I is equal to tacos at index I plus 1. And then tacos at index I plus 1 is equal to the temp. And also, we did swap, so let's assign swapped is equal to true. And now, we've simply gone back and used bubble sort, but in this case, we used bubble sort on objects. More specifically, we bubble sorted tacos based on their price. we checked whether or not they existed, so we checked their memory addresses, and if they are not null, then we check side by side if this taco's price was greater than that taco's price, then we just swap the values. Now the last method that we need to write is simply enough printing out the tacos to the console. Public void print tacos. Now I could easily use a for loop to do this, but I want to introduce a new type of loop. This type of loop is really great for processing every single element in any kind of collection, like an array. This type of loop is called a for each loop. So for each taco in tacos. Now as we can have null elements, I need to, if this taco is equal to null, well, we need to break. But if not, system.out.println taco. So this is a special type of loop called a for each loop. Let's take a closer look at how this works. So a for each loop is just a very special version of a for loop. What it does is it stores each element in a temporary variable. So how we use it is we first define one instance of this type collection, and we provide an identifier here. This is the temporary identifier that every single element is going to be stored to. These are great for looping through every element in a collection like an array, but you should not use a for each loop when you're modifying the data structure. You shouldn't use it when you're adding new elements or removing elements. A for each loop assumes that the data structure will not be modified. Now to look at this, basically, here's the for loop and here's the equivalent for each loop. So we start here for int I is equal to 0, I is less than tacos.length, and then we just create this instance here, taco t, and assign it to each one of the elements one at a time and then print it out. Now over here, this is just a for each loop that does the exact same thing. If you prefer to use a for loop, use a for loop. But I wanted to show an alternate version. Now let's get back to the code and write the front end. Now the last class that we have to write is the Taco Manager front end. Taco Manager FE. And this is going to include our entry point, the main method. I'm going to go ahead and take out this comment and make sure that I put my name at the top here. Now the purpose of the front end is to provide access to the back end functionality. So how we add, remove tacos. What we're going to do is use the console to do this. So we're going to import java.util.scanner, that way we can use the type scanner. In the UML class diagram, we described that we were actually going to use some static properties. Like for instance, we're going to create a private static scanner. Keyboard is equal to new scanner system.in. Now remembering back, static methods and static properties are static in memory. They are created once inside the data section of memory. The reason why we made this static is simply enough we can call this from the main method and any other method that is also static. We're going to do the same thing with a private static taco manager. Taco manager is equal to new taco manager. Now this static property can be used by any other static method. And since we only have one instance of each of these, we just decided to make them statically. We're going to get to the main method in a minute, but the first thing we need to do is print the greetings. Well, I want to be able to directly call this from my main method, so I'm going to create the method public static void print greetings with simply system.out.println welcome to the taco manager. And now from here, I can call print greeting directly. Remember, static methods can directly call static methods. Static methods cannot directly call non-static methods. Let me show you this. Let's say that I took out static here. Notice what happens. Because I took out the word static, this is now a dynamic method, and a static method cannot call this without creating an instance of this Taco Manager front end. So for simplicity's sake, we're just going to make this static as well. Now the next thing I'm going to do is create a boolean quit and assign that to false, and while not quit, we're going to keep running this code. Now before the user inputs anything, we should prompt them with their choices. So simply enough, this feels like a separate action, so we're going to create another static method to print out the choices. Then inside the while loop, we're just going to call print choices. And it's simply enough going to print out enter 1 to add a taco, 2 to remove a taco, or 9 to quit. So from there, we're going to create an int choice and assign that to keyboard.nextInt. Because we made this property static, we're now able to use it inside of our main method. And more importantly, we're going to be able to use this in any other method that we define as static. Now the next thing that we're going to do is whenever the user selects one of these choices, we're going to run whatever that action is from our Taco Manager. Now I'm also going to do this in a slightly different way. I could easily create an if, and else style of statement, but I'm going to show you something different. This is called a switch statement, and we're going to switch on this choice. Well, this is different. What is a switch statement? So a switch statement is a special version of an if, and else statement. Now notice, inside of its arguments, this is not a Boolean expression. It's what's called a controlling value, and they correspond to the values given by these things called cases. So the controlling value could be an integer, a character, an enum, or a string. So assuming this were an integer, you check if this integer is equal to this case, else if this case, or else that. Now you may also notice that we have break statements inside of this switch. Break statements are needed to stop the execution of the following cases, and without the break, the following cases will run or fall through. So if we didn't have the break here, it would run case 0 statements and also case 1 statements. It's always a good idea to include the break inside of each case. Now what we could have done is create this int choice and then have choice equals 1 or 2 or 9. But to do something a little different, we're going to have switch on this choice as being 1, 2, or 9. What you see here and here are absolutely equivalent. I just wanted to show a different way to do it. Now going back to the code, I'm first going to add keyboard.nextLine. That way we don't run into any weird errors. Now inside the switch statement, case 1. Case 1 is where we add a taco. I'm going to fill that in later. Case 2 was where we remove a taco. Then, case 9, well, this is when we quit. So we're just going to assign quit is equal to true. And break. And then finally, the default case, the else, well, this means they inputted something that wasn't 1, 2, or 9, so we're just going to say it was an invalid input. Now after this switch statement, I'm going to call taco manager.print tacos. That way we display all of the elements that are currently inside of the taco array that's being managed by the taco manager. So now we need to add and remove these tacos. Well, wait a second, both of these feel like different functionality, so why not create a method? Scrolling down a little ways, that way we can directly call it from this. I'm going to create a public static void add taco method. Now notice we prompt the user. Then we get all the attributes for the taco from the command line. So we get the name by keyboard.next line. Then the location, same thing, and then the price, pretty much the same thing. And then notice this. The instance of taco manager, we call the method add taco, then we construct a new instance of this taco using the parameterized constructor name, location, and price. So this constructs, it creates a new instance of this taco. Then, using this method, it adds it to our taco array that's being managed by our taco manager. We were able to use both the scanner keyboard and this taco manager because we made them static. We can use these in every single method. And similarly, what we're going to do is also create the method remove taco. So, enter the name of the taco to be removed. Then we have the name here. Then we just call remove taco from here to remove the taco by that given name. Now to make sure that all of this works, now all I have to do is call the static method add taco and remove taco. So now let's test this out. Running our software, let's add a taco. Let's say, I don't know, let's keep it simple. The name, ASDF, location, ASDF, or ADF, and the price, we'll just make it 1. And then it printed out the taco that had the name, ASDF, location, ADF, and the price, which is 1. Let's add another one. I don't know, ASDF2, ASDF2, and 2. Well, there we go. Now we printed out both of these that have been added to our collection using that taco manager. Let's add another one. ASDF3, ASDF3. Let's make this taco be, I don't know, 99 cents. Notice this. It also sorted it by the price. This was the cheapest taco so far, so now it's sorted from the least to the most. Let's try this. Let's try to remove a taco by the name. Let's remove the first one, ASDF. Now notice we have the 2 other tacos remaining and the other one has been removed. Now I'm going to enter 9 to quit. It prints out one last time and this program has ended. Now before we conclude, we have gone over a lot of different concepts and I would like to show how this worked inside of memory, how we both added and removed the tacos that we just witnessed. So let's just start from the beginning. Let's assume, just for argument's sake, when we called the method init, let's say that size happened to be 4. Now we used the default size, but let's just assume that we did set it up to only be size 4. Now what happens is this. 4 is greater than 1, so then we construct a new instance of this taco array, just like this, where we have 4 elements and all the memory addresses are set to null. Then we assign the instance variable tacos to the memory address of this element. Now let's say that we're going to add a new instance of a taco. Now here's the thing. Whenever we called new taco, and let's just say we called the default constructor where the taco's name was none, location was none, and the price was 0. Remember, a taco, as this parameter right here, is only a memory address reference. So first thing, if tacos at tacos.length minus 1 is not equal to null, well, this is equal to null. So we ignore that, and we move on. Now we enter this for loop. For int I is equal to 0, I is less than tacos at tacos.length, I++. So we're looking at tacos at index 0 right here. Tacos at index 0 is null. And so what we do is we assign the value of a taco, which is the memory address, to the memory address here, and it becomes 256. Now that parameter was pointing to that instance. Now tacos at index 0 is pointing at that same instance. When we break out of the loop, and then we are going to leave this method. When we leave the method, this no longer exists. The parameter aTaco is gone. However, we still have this reference inside of our array as the first taco. Now, let's add another one. If we're going to add another taco, now in this case, the parameter aTaco simply holds the memory address 326. We start index I at 0. Tacos at index I, well, this is not null. This refers to memory address 256. So we increase I by 1, and now I is equal to 1. Tacos at index 1 is null. So then we assign tacos at index 1 to be the memory address 326. This now points down to here. We break. Now once again, the parameter aTaco no longer exists. However, we still have the reference right here. Now let's say that we were going to remove the taco that had the name ASDF. And let's say that was the second element here. As you notice, this taco's name is ASDF. So entering into this method, we set this remove index to be -1. Then we go through the for loop and we establish int I is equal to 0. Then we check if tacos at index I is not equal to null. Tacos at index 0 is not null. We need to get the name, and then we call .=ignore case on the name. Now remember, this is tacos at index 0, which points to here, and this taco's name is none. None is not equal to ASDF, so we ignore that. We increase I by 1. Now if tacos at index 1 is not null, and it's not, it refers to this object right here. Now we check. This taco's name, is its name equal to a name? And in fact, it is. This is when we set the remove index to index 1. Then we break. Now the remove index is not equal to -1. 1 is not equal to -1. So then we enter this for loop, where we assign int I is equal to the remove index. Then we shift all of the memory addresses. So basically, tacos at index 1 is equal to the memory address found at tacos at index 1 plus 1, that's 2. And so tacos at index 1 becomes null. Tacos at index 2 becomes null. And then tacos at tacos.length, assuming this was length 4, 4 minus 1 is 3. We also assign that to null. And then we're done. Now, most importantly, notice this. We have the memory address to this taco right here. However, we have lost the reference to this taco that we're removing. As Java is a memory-managed language, it has a mechanism called a garbage collector. If we cannot reference this object in memory, it's deleted. Now, this has been a very long example, and it's gone over everything that we have discussed so far. We've also introduced elements of software engineering. We've also introduced the for each loop, and we've introduced the switch statement. Now there is still more to talk about, but until then, I'll see you next time.